All right, so working on number 1, area of a parallelogram is base times the height. The height has to be perpendicular. They give us the area, so substitute 70 in place of the A. That is the area.
What did they say right there? With the A?
Para, for parallelogram. So this is 70 equals, the base is what we are trying to find. Zach, please put that down. Times the height. And what is my height in this problem? 10. So substitute that in. It's 10. I am solving for the base. Okay? It is now being multiplied. So to get b by itself, what should I do?
Subtract.
Not subtract.
Add.
We're multiplying b times 10.
Times 10.
So we divide. Guys, we're multiplying. So to undo multiplication, we need to divide by 10. Divide by 10. 10 simplify out. And we get b is equal to 70 divided by 10, which is 7. And because they gave me units, it's 7 centimeters. So that is your base for problem number 1. What questions do you have about number 1? That's pretty straightforward. All right, let's take a look at number 2. Number 2, this also is a parallelogram. Okay? It has 2 pairs of parallel sides. All it says in looking at this picture is find the height. Well, I've got an h height here, and I have this other height here, which is 5 in blue. If I'm looking for the height of a parallelogram, am I looking for the height in blue, which is slanted, or the height in red? Which height do I need to look for? The red one, because it is perpendicular, okay? The problem is I don't have the height in red, but that side makes up a side of a right triangle. Okay, so I'm going to bring this right triangle down here and show that this side is 3, this side is h, and this side is 5. Can somebody get the door, please? So I am going to have to use Pythagorean theorem, which says a squared plus b squared equals c squared. The a and the b make up the legs. Zach. So this is a leg of 3. This is going to be my leg b. And the legs make up the 2 sides of the angle. And this third side is C, my hypotenuse. The hypotenuse is always the longest side. So A is 3. That's going to be 3 squared. Plus B is my H, my height that I'm looking for. And C is going to be 5 squared. So everybody see how I got those? All right, what is 3 squared? 9. And this is another thing I saw. You need to simplify these numbers out. Don't leave it as 3 squared. So I have 9 plus h squared equals 5 squared is how much? 25. And I'm trying to solve for the height. So I need to eliminate that 9. Subtract 9 from both sides. And I get h squared equals 16. But I don't want h squared. That's going to give me a whole square. I don't want a square. I just want h. So if you have something that is squared, you need to take the square root of both sides. And you're going to get h is equal to 4. And what label is that? Inches. Now, they said find the height. Did I find the height? Yeah, so I am done. But, and this answers your question, Zach, if they wanted the area of the parallelogram, and I'm just doing this for Zach, that's base times the height, which would be, your base is 8. This is the same down here. 8 times a height of 4 would be 32. Okay? All right. Now I need some space. Can I erase all this on the bottom yet? Because I need some space. Yes? Okay. I'm going to just clear the whole page. All right. The area of this trapezoid. This is a trapezoid right here. Trapezoid. Looks like a cut off triangle. Okay? So the area of a trapezoid is 1/2 times the height times the sum of your bases. And your bases are not usually, they are not going to be the same length. Okay? So that's how you can figure this out. So let's see. I have this height, which is 7. That's 7. And I have these bases. Usually we put base 1 at the top and base 2 at the bottom. Okay. Do you have this, Shania? Oh, okay. All right. So I need to find the area. So area equals 1/2 height. Is this 7 a perpendicular height? Yeah, they're showing me the box there. So I can use that 7. So that's 1/2 times 7 times the sum of my bases. Base 1 is 4 plus base 2 is 13. So on your calculators, everybody, I want you to do this. Actually, before we do this, what is 4 plus 13? Yeah, so let's mark this as 17 and say 1/2 times 7 times 17. So on your calculators, a couple ways you can do it. You take 1 divided by 2, that is your 1/2, times 7, and then times 17, what do you get?
59.5.
That is correct. So the area is 59.5, and if it's area, it's whatever your units are, centimeters squared. Because area, you are always trying to figure out how many little squares make up that entire figure. Any questions on that? Any questions? All right, are we done with it or not yet?
Yeah.
Okay. All right, let's go to your notes. Go back to 5 for just a second. And we finished the top of 5?
No.
You don't know. You're not even there. Yes. So go to page 5. Take a look at 5. Yes.
So, all I did is
Mm-hmm.
subtract, so I subtract in this for this right here, and then this right here, or do I do this?
To subtract for what?
Like, so when I added stuff in for
Uh-huh.
this, I add this or this one for this, for the second one. This one or this one.
4 plus 13.
Okay. Oh, that's
Yeah.
at the top. All right.
Mm-hmm.
Bet.
Yeah, because those are your
Okay,
bases.
the second one right here.
For the height.
Okay.
Mm-hmm.
All right.
Yes. All right. Really need to go?
I want action.
Okay. All right, so page 5. Actually, did you guys say we finished 5 at the top? Yes? Yes? No? All right, so go to page 6. Page 6. And we are talking about, as I recall, finding a missing measure. Finding a missing measure. I believe they give you the total area. Okay? I believe they give you, I can't even remember what the figure is. But we need to substitute the values that we do know and then find whatever is missing. The missing information. Okay, so let me bring this up. We're on example 7, correct? Yes? Example 7, is that right? Let's see. No, we're on top of 6. I think you guys said we finished the top, right? We're not going to do 5A or B. We're not going to do the check because I want to try to go over some problems with you. All right, here we go. So it says one diagonal of the kite measures 58.88 centimeters. All right. So they are showing you this length is 58.88. Don't worry that that's not down beside it. That's an easy way to show the entire length is 58.88. Okay? If the area, so they're telling us the area of the kite is 978.88 square centimeters, what is the length of the other diagonal? So we're trying to find the other diagonal. It's not going to be the same. As you look at it, doesn't this look a lot different? And looks are deceiving, but it looks like it's going to be shorter. All right, so this is a kite. You need to remember the old-timey kite. But we said kites and rhombuses resemble what kind of a sparkly feature? Shine bright like a diamond. So remember, they look like a diamond. And so remember the D from diamonds, we're going to use the formula with the diagonals. Okay? So that is area equals 1/2 times the diagonal sub 1 times the diagonal sub 2. Okay? We need to substitute what they give us. The area, they gave us that. So substitute that in for A as 978.88 equals 1/2 times the length of this first diagonal is 58.88. Now, the other diagonal here in blue, they didn't give me that. And they're saying X. I'm just going to leave it as diagonal sub 2. But you could put X if you wanted. Okay? You could put X if you wanted. Now, I want to get the length of this diagonal by itself. That means, since I am multiplying these other numbers by it, I want to divide, but guess what? We're going to solve and figure out what is half of 58.88 even before we start dividing. So on your calculators, everybody, take 1/2 times 58.88. 1/2 times 58.88. What do we get? 20 what?
29.44.
Yes, 29.44. So this is 29.44. Is everybody with me on that? So I'm going to divide by 29.44. And whatever I do on one side, you have to do on the other. Divide by 29.44. These are going to simplify out. So the length of diagonal 2 is, if you take 978 divided by 29.44, ugh, I can't hold two things at the same time. 29.44, what are you getting? 33.25. They gave us units in centimeters. Since it's not area, it's a length, it's just regular centimeters. So that is the length of this other diagonal, 33.25 centimeters. Okay? Alexander, are you with me? Okay. What questions do you have on that? So the hardest part here, or I think the hardest part to remember, is to take half of that number to get a single number, then divide by that single number on both sides. Okay? All right. I do want to do the check on this one. It is a little bit involved, okay? But I think we can do it. So here I have a rhombus. A rhombus is a slanty square. This is a rhombus. And they give us that AE is 7.3. So only this much of it is 7.3. Okay? The area of the rhombus itself is 96 square inches. That's a new piece of information. They want us to find X. Well, there's X. That's only half of it also. And they want us to find the length of each diagonal. Length of each diagonal. So we got a lot going on. What shape, it is a rhombus, but what shape does this resemble? Doesn't that look like a diamond again? So rhombuses and kites resemble diamonds. So they have the formula of area, well, let's do it in blue. Area equals 1/2 the length of diagonal 1 times the length of diagonal 2. Always start with the formula at the top. Okay? All right. So they give us the area, 96 square inches. Put that in place of A. 96 equals 1/2 diagonal 1. Do I have a whole length for diagonal 1? Can somebody let Blake in? I do not. But they tell me that this is 7.3, and it says this is congruent to this. So this length over here is also 7.3. So diagonals of 1 is 7.3 plus 7.3, which is 14.6 inches. So everybody see how I got that? We just double it. So diagonal 1, I'm substituting in 14.6. Now, it says I need to find x. Well, x is part of my second diagonal. If this much is x, and from length B to E is congruent from E to D, what is this length from E to D? What is it?
Which is what?
If BE has a length of x, what is the length of ED?
The same.
So what is that length? X. Now, here's the kicker. What is x plus x?
X squared.
It is not x squared.
1x, 2x.
It is 1x plus 1x, which is 2x. We're not multiplying, we're just adding them, right? So diagonal 2 is 2x. And that's how I have to leave it for right now. That's diagonal 2. Okay? We need to solve for x. So on your calculators, I want you to take 1/2 times 14.6 times 2. I want you to calculate all of this inside the black parentheses. 1/2 times 14.6 times 2. Ty, you with me?
14.6.
It is 14.6. Oh, come on. So I am going to divide by that number, 14.6, which means I need to divide by 14.6 on the other side. These numbers simplify out, and I get x equals, take 96 divided by 14.6. William, put it away. Get your calculator. No, it's not. 96 divided by 14.6. What is it?
6.575.
Right. It's a mess. 6.57. Let's round it to the 10th place because it says round to the nearest 10th. So I look next door. X is going to be 6.6. No, because we're rounding to the 10ths. That's all right. So 6.6, that's only half of it. So to find the whole diagonal, diagonal 2 is 6.6 plus 6.6, which is 13.2 inches. What? It looks confusing, yes. You need me to go through it a little bit more again? Yes? Okay. I actually did this up on the board, which I don't know if that's going to be helpful or not, but we'll start with that. So area equals 1/2 diameter, not diameter, diagonal 1 times diagonal 2. We have to know when we have a rhombus or a kite, that's the formula we use for both, okay? They gave us the area, 96. I put in 1/2, and for my diagonal, the first diagonal, they told us that it was 7.3 for half of it, right? And the diagonals bisect each other. That means it cut them in half. So I have to add, the other side is going to be the same amount. So 7.3 plus 7.3 is 14.6. And that's shown in this picture right here in red. If this is 7.3, this is 7.3 also. Does that make sense? So that is my first diagonal. Okay? So I substituted that in. Now, my second diagonal, which is over here in green, they said this was x. Well, if this is x also. So x plus x is 2x. And that, because I have to solve for the second diagonal, that's what I have to put it in as, 2 times x. So then, since we're solving for x,